catch me riding dirty, tryna 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 catch me riding dirty.
Hey everybody, we're back to our last chapter of organic chemistry before we start studying for our big test. Today's objectives are to identify, name, and draw molecules containing the amine functional group, and to identify and predict the products of the reactions that go with amines.
So first of all, we should talk about just what an amine actually is. To do this, I want you to first think back to the last group we looked at, which was the amides, or mids. The amide group was a nitrogen attached to a carbon with a double bonded oxygen on the same carbon, and there could have been potentially 3 carbon chains coming off the end. But if you remember, it didn't have to be 3 carbon chains. There could have been 1 hydrogen on the end. There could also be 2 hydrogens on the end, and it still technically classifies as an amide. When we look at an amine for today, you'll see the same nitrogen with 3 carbon chains coming off, just like amides. The difference is there's no double bonded oxygen anymore. It's just the 3 carbon chains. Also, just like amides, you could have just 2 carbon chains and 1 hydrogen. You could have just 1 carbon chain and 2 hydrogens, still classifying as an amine.
The amine can have different classifications to it. It could be primary, secondary, tertiary. Just like alcohols and ethers, what you're going to do is you're going to find the nitrogen, and how many carbon groups that are coming off that nitrogen is going to determine whether it's primary, secondary, or tertiary. So if we look at this one, it has 1 R group or 1 carbon chain coming off, so it's primary. This one has 2 carbon chains, so it's secondary. This one has 3 carbon chains coming off of it, so it is tertiary.
First of all, we're going to start with the easier ones. That would be naming primary amines. Like you see in the top right-hand corner, primary just means with 1 carbon chain attached to the end. And examples down below in the bottom right that we'll name together. First thing is the same as always. Find the longest chain with the NH2 group attached. That chain is, of course, the parent chain, and we give it the suffix amine. So in this molecule, the longest chain is circled in purple. There's 5 carbons in that chain, so we call this pentanamine. Second rule would be to number that chain from the end closest to the NH2. And because the NH2 could be anywhere on the chain, a number is needed to indicate the position of the NH2. So we're going to number, of course, from the right-hand side. That puts the amine on carbon 2, so this is 2-pentanamine. Lastly, just like always, find any other attached groups and list them out front. In this case, there's a methyl on carbon 4. Final names for methyl 2-pentanamine.
Naming secondary and tertiary amines are kind of like naming the amides with carbon chains that came off of it. Identify all continuous carbon chains attached to the nitrogen atom. The longest one will be the parent chain, and it is given the amine as a suffix. So here we go. We identified all the carbon chains. The largest one is bute, so we have butanamine. And then we're going to number the parent chain that gives the nitrogen atom the lowest possible number. So it's coming off the second one, so we have 2-butanamine. But we're not done. We still have to name the other carbon chains coming off the nitrogen. And they get the N as a prefix and are listed in alphabetical order. So we have N-ethyl and ethyl, since they're both ethyls, 2-butanamine.
Here's a slightly different example. If you look at the nitrogen, it has 1 hydrogen this time, so there's only 2 carbon chains to deal with instead of 3, like in the last example. So you identify the longest versions of those 2 chains. There's a prop and a pent. The longest of the 2 is the backbone, so that is, of course, the pent. So that gets the suffix of amine, making the parent chain name pentanamine. You have to number the parent chain to see where the N is attached to. It's attached to carbon 2, so it's 2-pentanamine. The opposing group, since there's only 1 of them this time, you just list 1 version of that with capital N-propyl. We also do have a methyl group attached to the backbone coming off of carbon 3, so this is 3-methyl. Notice where we list it. Since it's attached to the backbone, it gets listed before the backbone, not in front of the N-propyl. If it were attached to the N-propyl here, you'd have to list it out in front of the name.
Well, it's reaction time here on the tutorial. Let's take a look at amines reacting as bases. When amines are placed in water, they produce a basic solution by reacting with the water. A hydrogen is removed from the water and attaches to the nitrogen atom in the amine. Let's take a look. This is exactly what I said. We have the amine right here. We're adding a little bit of water, and this hydrogen is going to attach to the nitrogen. Alright, so what that's going to do is it's going to give the nitrogen a +1 charge. It has more bonds than what it normally likes. And the OH is going to have a -1 charge. And remember, when you have hydroxide ions, the OH ion, in water, that makes it a basic solution.
The second reaction you have to know is called alkylation of an alcohol to form an amine. The way this works is an alcohol is reacted with ammonia, special molecule NH3, to produce an amine and water. Here's a general example. Any carbon chain with an OH, that's your alcohol, plus the ammonia, is going to have that carbon chain with the amine on it. So the same carbon chain that was with the alcohol now has the NH2, and water is also a product. This is almost the reverse of the previous reaction. Here's a real example. Your alcohol has 2 carbons. If you react this with NH3, you put those same 2 carbons, except instead of the alcohol, now there's an NH2, and you also are going to have water as a product.
Alright, let's go over some uses for amines. Amines are extremely common in many biological processes. The breakdown of amino acids, which are the protein building blocks, we'll learn about that in the next unit, releases amines. The most well-known case of this is the decaying fish which smell of trimethylamine. And that's this little molecule down here. It's a tertiary amine because there's 3 carbons coming off of the nitrogen. Many common neurotransmitters contain amines such as epinephrine and dopamine and serotonin. We'll also go through some of these in the next unit as well. And there's many, many, many more which you can explore at your own leisure.
Alright, so to recap what you saw today, we looked at how you name molecules and draw them that contain amines, the NH2 group, both for primary, secondary, and tertiary cases. We also looked at some products that amines undergo as bases and as the alkylation reaction with alcohols to produce an amine. If you have any questions on anything you saw, please bring it to class.